So the aircraft is on a constant heading, which is not given in the question, and you have a 12 degrees of port drift. So as we have discussed before, any drift that is not derived from ADF is a planned drift. Yes, that's the first understanding. So planned drift is given as 12 degrees. This time it's a port drift. Now, it's making good a track of 5 nautical miles right of center line. So making good a track means the track made good. So track made good is 5 nautical miles. This time it is right, unlike the previous question. It's right of the center line. The center line is defined by the NDB. We have seen that just now. And we are asked to find out the ADF reading for NDB, which is situated on the center line. And this time the NDB is
behind.
That's right, 30 nautical miles behind, right? So let's look at all this information here. So we have the planned drift given, and to draw a line, I need the track. Since to find the track, I need the heading, and you have to assume. You can assume the track also, not just the heading. If you want, you can assume the track. That doesn't different. So let's assume a heading here. You don't have to.
I am assuming that 090. So I can start from that also.
From track.
From 090 to track, then
yes. You're just doing a reverse process in the beginning. That's all. Everything else will be the same. So we can assume. Let's assume a track here then. Let's assume a track of say 090, different one. You can choose your own tracker. You don't have to exactly copy this. You can just follow it because they're not asking for a particular value. They're asking for the ADF indication. It's independent of your heading, right? So assume track is 090. This is basically, I'll take this as a planned track.
Yes.
And now, because I can apply the planned drift only to planned track, because the planned drift is 12 degrees port, therefore what is my heading? 12 degrees port means track is port of heading, therefore the heading is going to be 090 plus 12.
Plus 102.
102 mathematic. Let's draw the NDB. Let's draw a track of, planned track of 90. The planned track of 90. Let's draw the NDB. Now, what can you identify on the planned track is just your destination. You cannot identify the aircraft on the planned track. To identify the aircraft, you have to draw the actual track. Right? Now, how will you find the actual track? In the question, it is given that the actual track is 5 nautical miles right of center line. Where is the NDB? NDB is 30 nautical miles behind the aircraft, which means the aircraft has to move away from the NDB. Only will then the NDB be behind the aircraft. So it is moving away from the NDB. Therefore, 5 nautical miles right is more towards right of the planned track. So track made good is right of the planned track. So right is this. If you identify it wrong, your right goes up. And your the ADF indication is going to be less than 360 for less than 180 if it is supposed to be more than 180, or more than 180 if it is supposed to be less, reverse, right? So here the aircraft is moving away from the NDB, and so what's the track made good? How will you find the track made good? So the aircraft is to the right of the planned track by 5 nautical miles. So the aircraft is there. Now you see this is the actual track followed by the aircraft now. So starting from here to reach here, this should be the track made good. Right, so the aircraft is right here. Now how will I place the aircraft? I need the heading. We got the heading as 102. Right, so this is 90. This is parallel. Therefore 102 is somewhat in this direction over here. Right, let's find the track error before we place the heading. Measure from the planned track towards track made good is track error. How will you find the track error?
Distance off by distance gone.
Distance off by distance gone into 60. What is distance off? Just 5 nautical miles. Distance gone is how much? From the question, that's right. NDB is 30 nautical miles behind. So this being 30 for smaller angles, you can take this distance also as 30. Therefore, this 30 nautical miles into 60. Therefore, it is a same 10 degrees. You can see 5 nautical miles for 30, 1 and 60 says it's 10 degrees of track error. Right? Therefore, what is your track made good?
It is 100 degrees.
100 degrees, yes. So let's place the aircraft now. So this is a parallel track. Yeah, this is a parallel track of 90. This is 100. What's the heading? Heading is 102, which means the aircraft is a bit more tilted towards the south.
Yes.
By 2 degrees here.
Yes.
Is 103. Understood? That is why I thought of finding the track made good first, so I can place the aircraft conveniently as 102. Now you're asked to find out the ADF indication. To understand the ADF indication, let's draw the dial here. What is the needle going to point towards? It's going to point towards the NDB, which is straight here. Right. If it is an RBI, the head of the RBI is going to be 360 and the tail is going to be 180. You're asked to find out the indication. How will you find out?
Then this is 10 and
so this is going to be 180 minus value. So this small angle will be if we just extend that line, that's 2 degrees.
Exactly. This is going to be 2 degrees. Therefore, this is also going to be 2 degrees.
2 degrees.
Therefore, what is the indication will be 180 minus 2.
180.
minus 2, there are 178.
178 will be your ADF indication. So in this question, unlike the previous question, there is no concept of flying parallel, because remember in the previous question we were coming inbound. So the aircraft was coming inbound parallelly and then trying to track towards the NDB. In this case, the aircraft is moving out of the NDB on a diverging track. Therefore, there is no parallel concept here. You just have to find out the ADF indication. So just to recap the main points here, number one, you have to understand that the drift is given as a planned drift. Therefore, whatever you find out is a planned track, not the actual track. What you find on the planned track is your destination. What you find on the actual track is your aircraft. While crossing